Okay. There we go. All right. So 4.2 is all about reflections. So we're going to get real introspective here. Um, no, we're going to be reflecting like reflecting in a mirror. So today we want to be able to graph a reflection and then also identify a reflection that has happened from a graph. So to get started, you guys are going to need your notebook or paper and something to write with. And then in the chat, what do you know about reflection, or what does that word reflection make you think of? Have we heard of this before? Might take a bit to shake off the cobwebs here. Have we heard of reflection before? Mirror, that's a good word. Opposite, nice. Yeah, those are definitely good words that go with reflection here, the kind of reflection that we're talking about. Good. In middle school or elementary school, if you've talked about translations and rotations and reflections and stuff like that, you might have heard this one called a flip transformation, because we are going to be flipping an object over a line or kind of mirror imaging it. So let's get started. Four 4.2, reflection. Get the mouse out of the way. Okay. Okay, so reflection is just flipping a shape over a line. And so for those of you with really good spatial awareness, this will be particularly easy to visualize. For those of you without very good spatial awareness, that's okay. We'll have, ways that we can do this um, that help us to identify the reflection just by doing things as simple as counting. So with reflections, there's always this center line that you are flipping the shape over. It's called the line of reflection, or sometimes called the mirror line. Yeah, sometimes it's called the mirror line because we are creating mirror images here. So line of reflection or mirror line, and this will be kind of the instructions um, that we're given. It'll say, reflect the shape over the line x equals 3, or reflect the shape over the line y equals 1, or reflect the shape over the line y equals x. So things like that will be our instructions here. Okay. Or sometimes it'll also be called the axis of reflection. Yeah, so line of reflection, axis of reflection, mirror line. Those are all vocab that you might see regarding reflections. Okay, so when we're talking about these lines, there's a little bit of vocab that we're going to need to deal with here. So the first bit of vocab or things that we need to remember are what these lines look like when we say something like y equals 4. One moment. Okay. All right. So when we see something like y equals 4, we need to know that that means that that is a horizontal line. At up 4 on the y-axis. So anytime you see y equals anything, that's going to be a horizontal line. And then something like x equals 3 is a vertical line. At right 3 on the x-axis. So that's some important stuff to remember here when we're talking about what we're reflecting over. So again, x equals 3 is going to be right here. Y equals 4 would be if you go up 4. Right there. But not to be confused with the y-axis and the x-axis. So the x-axis still goes horizontally, the y-axis goes vertically. So that's what people kind of sometimes have trouble with here, identifying the lines. They think, oh, the y-axis is vertical, so y equals 4 is going to be vertical. But that's not the case. We want the place where y is always 4. So y equals 4 is actually telling us to go up 4 on the y-axis and make a line. X equals 3 is telling me to go over 3 on the x-axis and make a line. Okay. So kind of the second thing that we need to know about reflection what we're going to be doing with our shape, or kind of our instructions here, is we're going to count the number of spaces to the axis of reflection. Then count the same number of spaces past that line and make a new dot or a new point. Okay. So the first thing that we needed to know is how to find the axis of reflection. The second thing we need to know is how to actually do that reflecting. So that's best illustrated with an example here. So the first thing we're going to do now is make ourselves a nice coordinate plane. Okay. So we do our best again to space them similarly apart, but if it's not perfect, that's okay. So the first thing I'm going to do is we're going to be given an original shape. So my original shape is going to be ABC, and it's going to be over, let's see, -3 up 1. That's point A, -3, 1. Point B is going to be -5, 2. And C is going to be -2, 4. So that's my original shape that I might be given. And then our instructions is going to be to reflect ABC over the line x equals 1. Okay. So then we need to find our line of reflection, x equals 1. So that means we go over 1 on the x-axis and we make a line. And then once we've done that, we just have to count the amount of spaces from here to the line and then count the same amount of spaces in the other direction from the line. So starting here at -2, 4, I have to go over 1, 2, 3 spaces to get to the line. So that means I need to count 1, 2, 3 spaces before I make my new dot C prime. Then we're going to do the same thing with A and B. So from B, I have to go over 1, 2, 3, 4, 5, 6 spaces to get to the line. So that means I'm going to need to go 6 spaces past the line. So we go 1, 2, 3, 4, 5, 6 spaces, and it's a little bit off the graph that I drew to get my new B prime point. Then we're going to do the same thing with A. A is here at -3, 1. So we're going to go over 1, 2, 3, 4 to get to the line. So we have to go 1, 2, 3, 4 past the line to get my new A prime point. And then we connect the dots. So my shape over here should be the same size as my shape over here. It just looks like it's been mirror imaged over that line of reflection. So it's been flipped over that line of reflection. Okay, so you just count the number of spaces from that point to your reflection line, and then you count the same number of spaces past that line to make a new point. So looking at that example, are there any questions at the moment? Anything we're wondering about? Anything we're not sure how to do? Okay. Hopefully this is going to be fairly simple for us today. We're going to do another couple of examples. We'll show you one where the shape kind of overlaps itself a little bit, and what to do in that situation, even though it looks a little bit messy sometimes. And then we'll also talk about how to reflect over a diagonal line. All right, so for example number 2, we're going to draw ourselves a nice new coordinate plane again. Is A on point 5 or 4? A is on 5 right here, so it's over 5 up 1. Good question. And this one, B is over 7 up 2, and C is over 3 up 4 for your new points. So A was over 3 here. So it was over 3 up 1. But to get to my line here, since my line is at x equals 1, I had to count 4 over. So from here to the y-axis, it's 3, and then we have to add 1 more onto that to get to our line of reflection, and then go 4 beyond that. Yeah, good questions. Okay. So here we go. Let's try another. One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So again, doing our best to make our lines roughly the same distance apart. It's hard to do. But the better we do with it, the more accurate our shape will look. Okay. So this time, we're going to start with our original shape at, we'll go, A is -1, 4. So 1, 2. And then B is going to be -3, -1. C is going to be at 1, -1. And D is going to be at 4, 4. And our instructions are to reflect A, B, C, D over y equals 3. Okay. So reflecting over y equals 3. So the first thing we have to do is draw the line y equals 3. So y equals 3 is at up 3 on the y-axis. So 1, 2, 3. There's that line, y equals 3. And again, we're doing our best to draw a straight line, but sometimes it's kind of hard. Okay, so that line runs through the shape. So that means that some of my points I will be counting down and past it. Some of the points I will be counting up and then past it. So here we go. So starting here, we'll start at point D. From D, I have to go down 1 to get to the line. So then I have to go 1 past it. Here's D prime. Then for A, I also have to count down 1 to get to the line. And so I go 1 past it. And there's A prime. Then for C, I have to go up 1, 2, 3, 4 to get to the line. So 1, 2, 3, 4 past it for C prime. And then for B, we have to go up 1, 2, 3, 4 to get to the line. So 1, 2, 3, 4 past it. And then we connect our new dots. Okay. And so again, our shape should look pretty much the same as long as we, counted correctly and everything. So if your shape looks drastically different, um, or it doesn't look like it was mirror imaged in the line, then something might have gone wrong. And that's where we would want to go back and try counting again or something like that. Okay. Any questions on this example? Okay, I'll give everyone a moment to finish writing before we do one more. Or one more reflection and then one noticing what it's been reflected over. Okay. This time we're going to reflect it over a line that is not vertical or horizontal. It's going to be diagonal. This time we're going to reflect over the line y equals x. So again, we're going to draw ourselves a coordinate plane. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So for my original shape, point A is going to be over to -1, up 1, 2, 3, 4. And this one is going to be important to have the coordinates written down. And you'll see why in just a moment. Point B is going to be over 0, up 3. And point C is going to be over -2, up 1. There's our original shape. Okay. And this time we are going to reflect ABC over y equals x. So remembering back to algebra where the line y equals x lives, the line y equals x is a line with a slope of 1 and the y-intercept at 0. So that means we're starting at 0, 0 and going up 1 or over 1, up 1, over 1, up 1. So that we get something that looks like that. All right, so there's the line y equals x. When we reflect over the line y equals x, there's a special rule of what you can do. And it is to switch the x and y coordinates. So for example, if I start with A is -1, 4, A prime is going to be 4, -1. We just switch the order of the x and y coordinates. So then I would go over here and plot over 1, 2, 3, 4, down 1, and that is A prime. Then we do the same thing for B. B starts off at 0, 3. So we switch X and Y and it becomes 3, 0. So over 3 up 0. And this one's not the best drawing of 4, -1. We'll move that over. So there we go. Yikes, some of these points are getting big and not well drawn, but oh well. Okay, and then for C, same thing. -2, 1. Switch the order. C prime becomes 1, -2. So over 1, down 2. And there's our new shape. And it's been reflected over this diagonal line y equals x here. So when we reflect over y equals x, we just switch the x and y coordinates around. Okay. And then for reflecting over the line, so this is one of the diagonal lines that you'll reflect over. The other one that you will reflect over is the line y equals -x. And so y equals -x, just a quick picture, looks like this. It's a line with a slope of -1 that goes through the origin. And so to reflect over y equals -x, it's a very similar rule, but slightly different. So for reflecting over y equals -x, you switch x and y and change their signs. So if we were doing this with this set of points here, where A is -1, 4, B is 0, 3, and C is -2, 1, what these would switch to, if I was flipping over y equals -x instead, A prime, we would switch the order just like we did here, but we would also change their signs. So since this is a +4, it would become a -4. Since this is a -1, it would become a +1. Okay, same thing here for B prime. Since we switched them, it would be 3, 0, but since we also changed the signs, it would be -3, 0. And then for C prime, since this was -2, it will become a +2. Since this is negative, or since it's +1, it will become -1. So we would get -1, +2. So you switch the order and you change the sign. So this is kind of a side note. If you were flipping it over y equals -x instead. And that's pretty much the only other diagonal line that we are going to ask you to reflect something over. So that's a different rule for that one. Okay. Any questions up to this point? Okay. If you do have any, either type them in the chat or say something. The last thing we're going to do really quick is show one quick example of how we would recognize what line something has been reflected over. Okay. So my original shape is going to be over 2, down 2. Over 4, down 1. and over 3 down 5. And the new shape is going to be over -2 down 2. Over to -4 down 1. And over to -3 down 5. And we have to figure out what the line of reflection is here. Okay, so there's a couple ways to do this. The first way is you can count how far it is between two of the corresponding points. So I could count over and go, okay, 1, 2, 3, 4, 5, 6. There are 6 units from C to C prime. So if I take that difference and divide it by 2, that gives me 3. So I know that if I go over 3 from this point, 1, 2, 3, then that's going to be my axis of reflection. And it turns out that it is the y-axis that's been reflected over. That's one way you can do it. The other way you can do it is kind of to eyeball it, but it's a little bit easier to go this way and find it exactly. So we might be asked, what is the line of reflection for this transformation here? Or what transformation occurred? And we would say that it was a reflection over the y-axis. Okay. So today's assignment is going to be in IXL. So that's where we're headed next, over to IXL. And I have to reload that page. So we have 2 sections today. One section is on reflections, and the other section is on lines of symmetry. So we want to reinforce that from yesterday. So reflections is L5, and it's going to ask you to do things like sign in. Let me find just a moment. Clever. So okay, we should be all good now. All right. So for this one, we are going to be reflecting across the y-axis. So here's the y-axis. And so what I'm going to do is simply count from this point. 1, 2, 3, 4 to get to the y-axis. So then I will go 1, 2, 3, 4 past it and put a new dot. Then I'm going to do that with this point as well. 1, 2, 3, 4, 5, 6, 7, 8 to get to the y-axis. So we're going to go 8 past it. And if you already know that that's going to be at -8 over here, you don't have to count. Then we'll do that with this one as well. 1, 2, 3, 4, 5, 6, 7 to get there. So 1, 2, 3, 4, 5, 6, 7 past it. And then we would click submit. All right, this one's also across the y-axis. So I'm going to jump a level here. We might be asked for the line y equals 1, which is right here. This one might be a little bit harder to count to just because it's not bold. So be careful with these ones. I'm going to count from V down 1, 2, 3, 4, 5, 6, 7, 8 to get to y equals 1. So 1, 2, 3, 4, 5, 6, 7, 8 past it. Then from W, I have to go down 7 to get to the line. So I go 1, 2, 3, 4, 5, 6, 7 past it. Same thing here for U. Actually, we're going to go with T next. 1, 2 to get to it. So 1, 2 past it. And then for U, 1, 2, 3, 4, 5, 6, 7 to get there. So 1, 2, 3, 4, 5, 6, 7 past it. The difference between this and your book is that when you plot your points here, you do need to make sure that you plot them in the order that they come. So like if I plot T, I don't want to plot V next because it's going to make a line between T and V, and I don't want that. I want my lines to be between T and U and V and stuff like that. So we do have to be a little bit careful with these. But yeah. So again, when you do one like this, make sure you are going to the line y equals 1 when you count. And make sure that you're counting then the same amount of spaces past that line before you make your new dot. Okay. So there's that one. I'll show one of the lines of symmetry one, and then anyone who does not need any extra help or want any more examples is free to go after that. On counting lines of symmetry here, it's going to show you a shape. And you want to count how many lines of symmetry does this shape have. This in particular one that we're starting with, I don't think has any. But this one has a line of symmetry right here. And that's the only line of symmetry that it has. So I would say one line of symmetry and submit. How many lines of symmetry does this one have? Also 1. So for all of those, it's going to be asking you how many lines of symmetry does the shape have? And you're going to put down how many you think it has. Okay. If you would like more examples of reflection, feel free to stick around. Otherwise, you are free to go start working on your assignment and have a wonderful day. I will post an exit ticket later on. If you decide that you would like more help, feel free to come back after you've done a couple or something like that. But yeah, have a good one.